Hello students, today we'll be learning about the history of the X-ray. The X-ray was invented by Wilhelm Conrad Röntgen, shown here. He received the Nobel Prize in 1901, the first one. When it was discovered, he actually wasn't trying to discover it. Before then, the only bones they saw were dead bodies. It was an accidental discovery, but a very vast one. You see.
X-rays. Basic information. It's a form of electromagnetic radiography radiation. Note: radiology is the branch or specialty of medicine that deals with the study and application of imaging technology. It's also known as Röntgen radiation. The first medical X-ray was of Wilhelm Röntgen's wife's hand. How interesting. X-rays are emitted by electrons outside the nucleus, which distinguish them from gamma rays. And aluminum or other X-ray filters are placed over the window of the X-ray tubes, filtering out low-energy beams. The function of an X-ray is simple. It is generated by an X-ray tube. It uses high voltage to accelerate electrons released by a hot cathode to a high velocity. Note: cathodes are the main source of electrons. Hot cathodes collide with a metal target, creating X-rays. Wow, don't you learn something new every day?
Oh, hello students, it's nice to see you again. Today the topic will be nuclear medicine imaging. A collaborative effort of scientists across different disciplines work toward this advancement, like physics, chemistry, engineering, and medicine. Two important scientists, Irene Curie and Frederick Julius Curie, shown here, were very significant contributors with the discovery of artificially produced radioisotopes. Widespread use of nuclear medicine started in the 1950s because of these advancements. They were very successful.
Nuclear medical imaging. Basic information. It's a branch of medical imaging. It diagnoses and treats disease based on cellular function and physiology rather than relying on anatomy. It treats certain diseases specifically, example cancer and palliative bone pain, and interpreting nuclear medicine scans. About 2/3 of the world's supply of medical isotopes are produced at Chalk River Laboratories in Chalk River, Ontario, Canada. Go Canadians. Radioactive isotopes combine with other chemical compounds or pharmaceuticals to form radiopharmaceuticals. Once ingested by a patient, radiopharmaceuticals localize to specific organs. It allows the medicine to diagnose or treat a disease based on irregularities in scanning.
Oh, hello. We're back again, I see. The CT scan history that we'll be talking about now. Now, it was discovered independently by a British engineer named Sir Godfrey Hounsfield and a British engineer named Dr. Alan Cormack. It became mainstay for diagnosing medical diseases and jointly awarded the Nobel Prize in 1979. This is Sir Godfrey Hounsfield. He was born in 1919 and just recently died. And this is Dr. Alan Cormack, born 1924, died 1998. The same. Now, that is all for now.
CT or CAT scan, otherwise known as computed tomography. Basic information. It is a medical imaging method employing tomography created by computer processing. Note: tomography is imaging by sections or sectioning through the use of wave and energy. While most commonly used in medicines, CT scans are also used in other fields such as non-destructive materials testing, aka scanning biological and paleontological specimens. Function. It produces data that's manipulated through windowing or in order to demonstrate various bodily structures based on their ability to block their X-ray beams. Digital geometry processing generates a 3D image of the inside of an object. Generated X-ray slice data using an X-ray source that rotates around an object.
Hello students. We will be looking at Gordon Brownell momentarily. This man is born in 1922, died 2008, this last year is very unfortunate. Now, He was the inventor of the PET scanner. He invented this in the 70s and spent most of that decade working on it. And also, the PET scanner, it's a device used to scan the brain, to scan for mental activity when people are performing mental tasks. The modern PET scanner is much different and more clear than the earlier versions. And that's pretty much all there is to it.
PET scans, or PET scans. Basic information. It produces a 3D image or picture of functional processes in the body. PET scans are usually analyzed along CT or MRI scans, giving both an anatomic and metabolic information. The Jülich Institute of Neurosciences and Biophysics has the world's largest PET MRI device. A short-lived radioactive tracer isotope is injected into the living subject. A waiting period is required in which the molecule gravitates toward the abnormal areas. Note: the most commonly used molecule for this purpose is FDG, a sugar that requires an hour-long waiting period to settle. A scan is then taken as the tracer decays.
Oh, hello students! Today we will be discussing the history of the MRI and those individuals involved. The MRI was based on a physics phenomenon in the 1930s called nuclear magnetic resonance, or NMR. The 2003 Nobel Prize in Physiology or Medicine was awarded to Paul Lauterbur and Peter Mansfield. Paul, shown here, is a good friend of mine. Fortunately, he died 2 years ago. It's tragic. He was a professor of chemistry at the State University of New York at Stony Brook. He wrote a paper on a new imaging of technique, zygomorphography. His work moved imaging from single dimension to second dimension of the special orientation, the foundation of MRI. Now, Peter Mansfield of Nottingham, England, also a good friend of mine, still alive. Wonderful man, very wonderful man. He developed the utilization of gradients in magnetic fields. Also showed how extremely fast imaging could be achievable. The first patent was Raymond Damadian discovered the basis for using magnetic resonance imaging as a tool for medical diagnosis. The patent was granted in 1974, and MRI was free to go and be used as a medical tool. Now students, you've learned a lesson. Study, be good. That's all for today.
MRI scans, otherwise known as magnetic resonance imaging. Basic information. It is a medical imaging technique commonly used in radiology to view the internal structure and function of the body. The first studies performed on humans occurred in 1977. MRIs are controlled by one or more computers, and its largest part is the magnet. Function. It is largely composed of water molecules which each contain 2 protons. When a subject enters the scanner, protons align with the direction of the magnetic field. Diseased tissues, such as tumors, can be detected because the protons in their different tissues return to their equilibrium states at different rates.